your thumb is already moving. There's a little knot of white froth tucked into the joint, where a leaf meets the stem. Wet, bubbled, sitting there like someone spat on your plant. And you're about to wipe it off, flick it, hose it down, tidy it away the way you'd wipe a smudge off a window. It reads as spit, or the first hint of mildew, nothing that deserves a second thought. The hand knows what to do before the mind even asks the question. Don't. Not yet. Kneel down. The real story starts lower than you're looking, because that froth didn't land there by accident, and nothing outside put it there. Not rain. Not a slug dragging through in the night. Not a sickness creeping up the stem. Somebody built it. Somebody is inside it right now, breathing, drinking, hiding. And the question worth getting your knees wet for is this. Who makes a house out of bubbles, and what is so dangerous out here that a creature would rather wrap itself in foam than face the open air? So let go of the word spit. It's the most natural guess, and it's the wrong one. There's no mouth involved. No spitting at all. What you're looking at isn't a mess somebody left behind. It's closer to a building site, still warm from the work. And to meet the builder, you have to part the foam. Do it gently. Slide the bubbles aside with the edge of a blade of grass. Slow, the way you'd lift a blanket off something sleeping. And there it is. One soft, pale, green-white creature, no bigger than a grain of rice. Round. Defenseless. No shell. No armor. Nothing on its body that could turn a beak or a jaw. This is a spittlebug nymph, and this damp little cloud is the only thing standing between it and everything out here that would happily eat it. Watch it for a second. It hasn't bolted. It can't. Really, it's barely built for moving, let alone running. It just sits, tucked against the stem, where it has been quietly doing the most surprising thing in your whole garden. Because the nymph made the foam itself, out of its own body. A study by Beckett and colleagues in the Journal of Experimental Biology in 2019 traced exactly how. The nymph taps into the plant and drinks xylem sap, the thin, watery stuff the plant hauls up from its roots. It's a poor meal, barely any goodness in it, so the insect has to drink an enormous amount just to stay alive, which means it always has fluid to spare. And it doesn't waste that fluid. It takes the spent liquid, threads and proteins and long sugar molecules from inside its own body, and turns plain waste into something with structure, something that can hold the shape of a bubble instead of bursting it. Then it draws air in through a groove along its belly and begins to pump, contracting over and over, working the liquid into froth from the inside out. In 15 to 30 minutes, a bare, exposed nymph vanishes under a dome of its own making. And it doesn't make a thin little film either. It will pump out many times its own body volume in foam. Sit with that for a moment. A creature the size of a rice grain, breathing out a fortress several times bigger than itself, from nothing but sap and air and patience. This isn't a leak. It isn't an accident of digestion. It's the first thing this animal ever builds, and it builds it before it can do anything else at all. So now we have the builder, and we have the build, which leaves the real question, the one this whole thing has been circling. Why? What is the foam actually for? Because if it were only a curtain to duck behind, a thin veil would do the job. This is far more than a curtain. It's doing several jobs at once, and each one is a small piece of engineering. Start with heat. A summer leaf in full sun is a brutal place to be small and soft. Researchers, led by Tonelli at the University of Sao Paulo, writing in scientific reports in 2018, put the foam to the test. When they pushed the surrounding air to just over 32 degrees Celsius, the inside of the foam held at around 30, roughly 2 degrees cooler. 2 degrees sounds like nothing, but 32 is the temperature that kills these nymphs. So the foam wasn't keeping the creature comfortable. It was keeping it alive, holding it on the safe side of a line only a couple of degrees wide. A nursery with its own thermostat written right into the bubbles. Then there's everything with legs and an appetite. To a spider or an ant, a soft nymph is an easy meal if it can reach it. A study in the Journal of the Royal Society Interface in 2024 looked closely at what the foam does to an attacker, and the answer is that it doesn't just hide the nymph, it fights for it. The froth clings. It coats and weighs down the body of whatever pushes into it. And because it dries about as fast as water, a predator that digs in finds itself, slowly held in place. The harder it struggles, the more the foam grips. This isn't a blanket the nymph cowers under. It's a snare the nymph sits safely inside. And if all of that still sounds like a tidy theory, scientists did the blunt, ruthless thing to find out. They took the foam away. In trials reported by Balzani and colleagues in the Bulletin of Insectology, in 2023, nymphs were stripped of their froth and then put in front of spiders and ants. The ones left without their foam died at a far higher rate than the ones still covered. That's the whole case laid bare. Pull the bubbles away, and the soft thing inside doesn't last long. The foam isn't a decoration sitting on top of the life. The foam is part of how the life keeps being alive. And here's what you walked up ready to wipe off your plant. While it's doing all of this cooling itself, trapping spiders, drinking its river of sap, it is barely touching your plant at all. To a garden, a spittlebug is mostly just the look of the froth and nothing more. Gardening references will tell you it isn't a serious pest. The foam unsettles people far more than it ever troubles the plant. So the thing your thumb was about to erase was never a threat to anything you care about. It was a small life, sealed inside a shelter it spent its first hours building, quietly getting on with the only task it has, to survive long enough to grow up. Which is where this story stops being about foam at all. Give that nymph a few weeks. Inside the froth it feeds and molts, and feeds again, soft and slow and completely out of sight. This is the first chapter nobody reads, the part that happens before anyone thinks to watch. The audience always arrives late to this one. And then, one ordinary day, the foam is empty. The curtain still hangs there on the stem, but the stage behind it is bare. The creature has finished its costume change, shed the role it was playing, and what steps out is nothing like what went in. It's called a froghopper now. Hard-bodied, blunt, a few millimeters of plain brown, nothing much the kind of bug your eye slides right past. And yet this unremarkable little insect carries one of the most absurd talents on the planet. Work from the University of Cambridge, led by Professor Malcolm Burrows, measured exactly what it can do, and the numbers barely sound real. It throws itself around 70 centimeters into the air. To get there, it accelerates at 4,000 meters per second squared, and in the instant it launches, it takes on a force of more than 400 times its own body weight. Guinness World Records lists it as the highest jumping insect ever recorded. It outjumps the flea. And here is the detail that closes the whole loop. The nymph back in the foam can't do any of this. It doesn't jump at all. It can't. That power belongs only to the adult, the one that already walked off stage. The very reason the soft thing needed a fortress of bubbles is that it hadn't yet grown the legs that would one day make it untouchable. The foam was buying time. It was holding a defenseless creature safe through the one chapter where it had no other way to protect itself, so that it could live to become, by some measures, the greatest jumper in the world. So look back at where your thumb was a few minutes ago. You saw spit, a smudge, a wet little mess to rinse off a leaf. What was actually sitting there was a soft, blind, jumpless creature that drinks a river of sap, turns its own waste into architecture, raises a shelter with a working thermostat and a snare for spiders built into the walls, and waits inside it for the day it can finally leap clean over the world. The foam was never the problem. The foam was the prologue. You almost wiped away the first page. So here's the only homework I'll ever give you. Next time you're out there, the garden, the grass verge, a tangle of weeds along the path, and you catch one of those little knots of white froth in the crook of a leaf, don't reach for the hose. Get down low. Slide a single bubble aside with a blade of grass, and find the small, soft thing waiting in there. Watch what it's doing for a moment before you stand back up. Then tell me what you found. I honestly want to know what's been quietly building itself in the joints of all the leaves you've been walking past your whole life.